Welcome to our 2110 design review. Let's jump right into our robot design.
So in general, our card can be divided into three mechanisms. The team escape mechanism, the ghost launching mechanism, and the motor gear mechanism. We're essentially using a piston driving a catapult, and so we can launch the team or the balls into the center slot of the car. And for the ghost escaping mechanism, we're essentially attaching a piston on top of a slanted ramp, so we can launch the balls at a certain angle, targeting certain slots in the center of the arena. In terms of as for the motor-driven gear mechanism, it's very intuitive. We just attach gears onto the motor axle, and then we connect it to the axle of the back wheels. And we can drift the car using the motor like so.
Hi, so I'm going to be talking about the system effectiveness. So our first thing is the actuator launcher. So far it's been quite accurate. It misses sometimes by bouncing out, but most of the time it hits in if the timing's right. This is our actuator arm. It's a little bit less consistent. The main thing being that the pressure has to be very precise so it doesn't bounce violently. And we've had these styrofoam plates that weren't there before. It's kind of like a jury rig, so the balls would more directly go into the hole. We also have this switch. This switch is pretty important. It starts everything, and our robot kind of inconsistently moves forward the right amount. Usually it's pretty much the same, and the way we position it helps it, but sometimes if it's pushed over or doesn't go forward the right amount, the switch won't be activated by the turning block. And then we decided that if the switch isn't hit, so we're going to have code that shoots anyway, and even if it's not in the right zone, at least we'll get some points.
Alright, so for our design ingenuity, moving the robot, instead of using two motors to drive each wheel, we decided to use a gear train. That way we can only use one motor and we don't have to worry about timing being wrong with two motors. And for our escapist arm, we decided to use the arm to convert the linear motion from the pneumatic actuator into circular motion. So we would be able to swing the escapist into the mystery machine.
Using the arm that a 3D printed part as this connector was too fragile and kept breaking. So instead we milled a piece out of metal, of some aluminum, that has been much more effective and has not been breaking as much. Also in the fabrication, we can look at our gears. Instead of just using one acrylic gear, we have an acrylic gear sandwiched in between two MDF gears. And now we needed the strength of the acrylic, but the acrylic was also really thin, so we decided that we wanted to sandwich it between MDF so that we can also get more consistency with the movement of the gear and it wouldn't pop off. Now as far as the creativity aspect goes, we wanted to go for more of a Villains of Scooby-Doo theme. So we've got our ghost colored robot, and on our robot we have a bunch of villains from the Scooby-Doo series, the original series, that we've put on. And also you might notice this little face we have on here, and this was kind of what led us to have this theme. When we were first laser cutting this piece, we didn't even know that this was here, and we turned it around and saw this face, and we're like, that's scary, so it must be the ghost of someone who's inhabited our robot. So we decided to go with that and make that our bigger theme.